So this start of notes starts at function notation, and we're actually evaluating what we do in function notation. So in the last video, I talked about how function notation is a way to label an equation, and this one, it's kind of like putting an input-output table like you learned back in elementary school. So what this is telling me is, when it says evaluate the following functions for f of 2, this is saying plug in 2 for x. So I'm going to go ahead and I'm going to rewrite everything in the equation, except every time an x appears, I'm going to write a 2 instead. Okay. So the left side of the equation with the f of 2 stays the same. This is telling me what I plugged in. The right side will tell me my answer, or my output. So I have negative 4 times 2, which is negative 8, plus 7. Then I want to combine like terms. So I have f of 2 on the left side still. Negative 8 plus 7 is negative 1. So this whole thing is my answer. It tells me I plugged in 2, I got out negative 1. I'm going to go ahead on number 2 and do the same thing. So I have f of 2 equals 2 times 2 plus 3. And since I'm writing in a different color pen, I just skipped the red 2's for now. Okay, so then I want to figure out what 2 times 2 is, which is 4. I have 4 plus 3, which is 7. So f of 2 gives me 7 on the second equation. Okay, on number 3, I am looking at an equation given context of a real-world situation. So f of t is the outside temperature in Fahrenheit, t hours after 6 a.m. So I got to figure out what each statement means. If I take a look at A, it says f of 0. This means no time has passed. So what I'm going to say when I write my answer for this is, at 6 a.m., it's 58 degrees. Okay. On B, it's saying f of 3. So f of 3 is 3 hours after 6, so 9. And 9, f of 9 is 9 hours after 6. So 9 hours after 6 a.m. is 3 p.m. So 6 plus 9 is 15. Time counts by 12. So 15 minus 12 gives me 3. And that's where the 3 p.m. came from. So what this is telling me, because remember, f of a number is telling me the temperature outside. So it's telling me at 9 a.m. it's cooler than it is at 3 p.m. Okay. Number 4 is a little bit different. It gives me the equation h of x equals 2/3 x minus 5, and it wants me to find the value of x. So this means I'm solving backwards. It then tells me h of x equals negative 7. So what I'm going to do is the two h of x's, instead of writing both of those, I'm just going to write negative 7 where the first h of x went. So I have negative 7 equals 2/3 x minus 5. And I'm going to go ahead and add 5 to both sides. I have negative 2 on the left, 2/3 x on the right. Then to get rid of my fraction, I'm going to flip the fraction, so multiply by the inverse, which is 3 over 2. And I'm going to go ahead and multiply by 3 over 2 on both sides, because what I do to one side, I have to do to the other to keep the equation level. I have 3 times negative 2, which is negative 6, divided by 2 is negative 3. And then over on the right side, the fractions cancel out, and I'm left with that. So my answer for number 4 is x equals negative 3. Oh, and I forgot to write a note over here to set the two equations equal. So what I want you to do is take a few minutes, look at the problems at the bottom, pause the video, solve them, and then I will be moving on to 3.4. Just kidding, there's some ones on the back you want to pause. So, pause right here, solve these two, and then I will be moving on to 3.4. So we're going to start off graphing linear equations. The standard form of a linear equation is ax plus by equals c. Horizontal lines have the form y equals b, and vertical lines have the form x equals a. So if it's a y equals line, it goes left and right. If it's an x equals line, it goes up and down. If I look at number 1, it tells me y equals 4. This means it crosses the x-axis. It crosses the axis opposite the letter that I have. I mean, did I say x-axis? I meant y-axis. It crosses the same. The axis? Not right at all. What am I even thinking? So it crosses the same one it does. So I'm going to go up 4 on my y-axis, put a dot as a placeholder, and then I'm going to draw a line straight across with some sort of straight edge. I can use a ruler, I can use my ID. Okay. I'm going to look at number 2. It's an x equals, so this means it crosses the x-axis. What I'm going to do there is I'm going to go left 2 because it's negative 2, and I'm going to draw my line up and down. I'll draw arrows on this so they're a little more easier for you to see. Moving on, I can use intercepts to graph a line. So something like number 3, I have both an x and a y. So what I want to do here is I'm going to solve for my x-intercept, and to do that I plug in 0 for y. So I have 3x plus 4 times 0 equals 12. 4 times 0 is 0. I'm going to rewrite that without the 0, so I have 3x equals 12. And then I divide both sides by 3. I get x equals 4. So what I'm going to go do is I'm going to go put a dot at 4, or x equals 4. Then I'm going to go do the same thing for my y-intercepts. And this one I plug in 0 for x. So then I have 3 times 0 plus 4y equals. Okay, 3 times 0 is 0 plus 4y equals 12. I'm going to rewrite this without the 0 out front, so I have 4y equals 12. Then I'm going to divide by 4 on both sides. Y equals 3. So then I'm going to go ahead and put a dot at y equals 3. At y equals 3. Then what I'm going to do is I'm going to connect the dots to make a line. And this is one way we can graph when we're graphing a centered line. So I'm going to show you the 3 on the back for you to practice, and then I will move on to 3.5. So pause, take a moment to solve these, and then meet me at 3.5. In 3.5, we're learning how to graph with slope-intercept form. The slope of a line is found by finding the change in y over the change in x. The formula for finding the slope of a line is m equals y sub 2 minus y sub 1 over x2 minus x1. Another way you might have seen this is rise over run. So on numbers 1 and 2, it wants me to describe the slope of a line and then go ahead and find the slope. This one, if I notice, it starts here and then it goes right. So it's going down and then right. This means it has a negative slope. We always read graphs from left to right, just like we read a book. Then what I'm going to go ahead and do is I'm going to go count those squares in that triangle I just drew. So I went down 2, so I make that a negative, and I went right 5. So my slope here is negative 2 over 5. If I take a look at number 2, I go up and right to go, it's not on the right line. I go up and right to go to my next point. That makes it positive. And then I went up 4, and when I did the correct line, I went right 6. So I have 4 over 6. Both of them are even, so I can divide both of these by 2. And it simplifies to 2/3 for my slope on number 2. Moving on, sometimes I'm given points in a table and asked to find slope. When this happens, I want to still find my change in y over my change in x. So my change in y here is I'm going down 6, and that's consistent for all the points on this table. And then for my change in x, I'm adding 3 all the way down. So it's a positive 3. So I have negative 6 over positive 3. That simplifies to negative 2. Same thing on number 4. I start by finding my change in y. I'm adding 5 between each of these numbers. And then for my x values, I'm adding 2. So my change in y was 5, and my change in x was 2. So my slope here is 5x. I'm going to show you the practice problems. I want you to take a few minutes to work on these 4. Pause, solve them, and then meet me on the last page of 3.5. So the last thing is graphing in slope-intercept form. Slope-intercept form is y equals mx plus b, and you might have learned this in pre-algebra last year. The m stands for slope, and the b stands for y-intercept. Okay. When it asks me to find the slope, this is the number in front of x. And the y-intercept is the number without the x. So my slope on number 1 is the number in front of the x, which is 3. My y-intercept is the number all alone without an x, which is going to be the negative 4. On number 2, my slope is 0. This is because there is no x. Then my y-intercept is the number all alone, so the 6.5. On number 3, I want to get y by itself. So I'm going to isolate this variable, just like we learned at the end of chapter 1. So I'm going to add 5x to both sides. I have negative y equals 5x minus 2. Then I divide everything by negative 1. I get y equals negative 5x plus 2. So my slope here, is the negative 5 out front. And my y-intercept is the positive 2 at the end. That's off the screen. On number 4, it wants me to graph 2x plus y equals 2, and then to identify the x-intercept. So what I want to do is I want to start off by getting x by itself. So I'm going to start by rewriting my equation so I can do that, because I don't have any room where it is. I'm going to subtract 2x on both sides. I get y equals negative 2x plus 2. Then to graph, I'm going to follow the following steps. I'm going to start by putting a point at the y-intercept. So my y-intercept is 2, so I'm going to go up 2 on the y-axis and put a point. Then my second step is to use my slope to find the next point. So this one, slope is always rise over 1, so what I'm going to do is if it's not a fraction, I'm going to make it a fraction by putting it over a secret 1. So it's got a negative 2 on top, so that means I'm going to go down 2 squares, and then it's got a positive 1 on the bottom, so I'm going to go right 1 and put my second dot. My final step here is to go ahead and connect the points. And I have graphed this. It also wanted me to say the x-intercept, so where it crosses the x-axis. And that would be the point right here. So the x-intercept is 1, 0. I'm going to show you the practice problems. Pause so you can solve the ones at the bottom of the page. And then I'm going to show you the ones on the last page, and then that's it for chapter 3. So pause, and have fun, and then meet me at the study guide video.